Good morning, everyone. It's a pleasure to be with you all this morning at the 8th Annual Economist Sustainability Week event. I'm Catherine Kinnicker, and I lead Strategy, Marketing and Sustainability at PTC. For those of you who don't know PTC, PTC is a global software company that provides a portfolio of digital solutions that help manufacturers transform how products are engineered, manufactured, and serviced. So the theme of this year's event is all about empowering businesses to accelerate action on sustainability. And it's not just businesses, it's NGOs, it's policymakers, financiers, investors, and the entire ecosystem to be better informed and armed to take action. So my hope for you is that at the end of today's session, that you will have some real tangible strategies for using data-driven insights that can be implemented by manufacturers across the entire life cycle. Now, the problem is really clear and probably doesn't need restating across this audience. We simply are destroying our wonderful planet. From a material perspective, we're using way more than the Earth's capacity. The amount of waste is at an all-time high. And for those focused on the manufacturing sector, we know that this sector alone accounts for 54% of global energy consumption. The good news here is consumer awareness is increasing, and they have a desire to buy cleaner products. Employees are putting sustainability as a top criteria when choosing which company to work for. And manufacturers agree that there's actually real value in environmental programs, and they're committing at a really fast rate. Now, manufacturers of physical hard goods, who often called discrete manufacturers, are driving meaningful environmental improvement in three key areas: better and less material in products, energy efficiency in production, logistics, operations and service, and waste reduction in production, service, and certainly in end of life. And beyond these benefits to the planet, the reality is that manufacturing more sustainable products is also very good for business. They are less risky in resource-constrained and resource-uncertain supply chains. Investors are putting more money into sustainable companies, and we're starting to see the market premiums for sustainable leading companies. But most tactically, and for today and for the here and now, manufacturers are seeking greener suppliers, and customers are seeking greener OEM products. And here's why. This chart is likely familiar to you. But for those of you who haven't seen it, it's the typical greenhouse gas reduction path for Science-Based Target Initiative committed organization. Most global firms have committed or are in the process of committing to footprint reductions. For most of the manufacturing sectors, about 50% reduction is committed to by 2030, and the harder 50% by 2050. However, over 90% of a typical discrete manufacturer's footprint is from the supply chain via Scope 3 emissions. This means that manufacturers must source greener materials and components. Firms must source greener OEM products. And so now manufacturers' footprint is a major buyer consideration. With this in mind, manufacturers are focusing on all aspects of a product's life cycle, from design, which includes choosing which suppliers, to how and where the product will be manufactured, to how it will be supported in operations and throughout its life cycle, and how best to service that product through the end of life of the product. Environmental sustainability and designing for the circular economy is now becoming a top 3 priority for our customers. So let's look at each stage of the product life cycle, and I will attempt to share some of the particulars and examples of what is already being achieved. First, let's look at the design stage. The reality is that 80% of a product's footprint is determined by design decisions. So this means that engineers no longer can just meet a specification anticipating small incremental improvements and changes over time. Now they must consume information across disciplines. And this augmented with artificial intelligence and simulation to inform how they can optimize both early and often. This includes selecting right material for performance, for cost, and for footprint up front. Use only the amount of material that is needed to meet the performance constraints, and verify that performance via simulation, and then rinse and repeat until the design is lean and mean. Here with me, I have an example of the impact of using simulation-led design techniques can have. This motor mount, which holds up to the weight of an 11-liter engine weighing 2,000 pounds for one of our customers' Volvo truck. The original motor mount is 44 pounds in weight. While using generative and AI techniques, we were able to design a mount to serve the exact same purpose, but only weigh 18 pounds. So using AI techniques in the design, we're able to create a mount that saves footprint in manufacturing using less materials, but is also even more so in operation, given that there's less weight on the truck. Now we have many other examples, and so I'll share one other example for the design stage by listening to a very innovative engineering group of both combustion and hydrogen-powered generation, Cummins. Let's see what changes they have already made in their design process to enhance sustainability of their products.
I'm David Genter. I am Director of Design Engineering for Cummins. We're the largest independent engine manufacturer in the world. For Cummins to maintain competitiveness of our products, we need to have the key performance indices of our products optimized in every way. The pursuit of optimization is what yields world-class products. So Cummins is taking every realm of how we manufacture and design products and looking to become carbon neutral as much as possible by the year 2050. The realization that 70% of what we do is locked in very early in the whole new product introduction process put the focus on design engineering specifically. When I realized that we had such a role to play in protecting our planet, it became for me one of the most noble things that I felt I could do as not just an employee of Cummins, but as a steward of the planet. Designing for sustainability, it has many flavors to it. The place where I'm placing a lot of my emphasis is to make sure that when we design a product, we don't design it with any more material than is required to attain its strength or stiffness goals. So it's really looking at the full life cycle of the product and making sure you're not using any more material from cradle to grave. And to do that, you need special tools like Creo generative, or things that tools that help you to understand where you are potentially putting wasteful material into the product. Some of the analysis tools within Creo enable us to do is to do the iterative work up front within design, where it's the most efficient place to do that type of work. Design engineering really does have a very important role to play when we're trying to meet our sustainability goals. We now know that when you apply these techniques, you can expect to save between 10 and 15% material use. And you can pretty easily understand or calculate what those benefits will be from a total CO2 perspective. But one thing really nobody knew until we did that work is how much that would translate to in terms of like overall cost savings over the course of the year. There was not only a big impact on the environment when you take that 10 to 15% savings and multiply that by the number of components that you make annually, but there's also a cost savings that comes with that too, and a weight savings, obviously. and the weight savings has compounding effects when that engine goes to work in a truck. So the less an engine weighs, the better fuel economy it gets. It really has a compounding effect. From a design engineering perspective, it really allowed our designers to go home at the end of the day saying that I saved $500,000 today, or I saved $200,000 today. And it really provided some value to their role that they had difficulty making tangible before we started this work.
All right, let's move to the manufacturing phase of the product life cycle. Manufacturing requires collaborative design and execution. And for example, with more than 150 gigawatts of wind turbines in 87 countries, Vestas has installed more wind power than anyone else. Each Vestas turbine is unique for its location and wind pattern. Additionally, the Vestas factory is actually its operating location. So turbines are assembled on location. So to manufacture these sustainably and with cost efficiency, Vestas uses modular design paired with manufacturing process planning. This gives the assemblers up-to-date, configuration-specific, visual work instructions to assemble with high quality and efficiency, even in the harshest, most remote conditions. Additionally, Vestas combines IoT to assist with the assembly verification, as well as the ongoing service after the turbine is operational. So using a lot of data to really effectively and sustainably produce its turbines and install them. Okay, so similar to Vestas, BMW uses manufacturing planning for a design anywhere, build anywhere strategy. Now, historically, big portions of the automotive cradle to customer footprints was the component and final product transportation. With using digital design and factories, BMW can source materials and manufacture vehicles in local markets, accounting not only for local vehicle options and choices, but also regional supplier and factory variances. Again, having a significant sustainability impact to that component and final production transportation part of the footprint. Let's move on to the operate and service phase of the life cycle. Here, a large part of the footprint is the activity involved in either sending experts to service a product or sending products to be serviced by experts, not to mention the ongoing training of all of these experts. Now, this is where digital technologies can really have a dramatic impact. Digital technologies across engineering-derived parts information and procedures, IoT, remote software updates, highly optimized spare parts management, and field service technician optimization and information, as well as technologies like augmented reality, can really reduce these high-carbon transportation events. A fun and compelling example is Royal Enfield. They created an augmented reality experience that enabled both their sales and their service teams to interact with the Meteor motorcycle during the training event. This AR experience using advanced model target technology allows the users to click onto different parts of the motorcycle to view the details about key features and watch videos describing the technology and more. Royal Enfield has recognized that this tool in the hands of their sales and service teams would facilitate the knowledge transfer of complex subjects and will help them better understand and retain relevant information about their new bikes. All right, another example of technology that can be used in the service stage of the life cycle is IoT, and really leveraging IoT-enabled application during that phase. One of our customers, Bell & Howell, one of the largest service provider organizations in the world, is doing just that. And they are getting remarkable results that are both cost efficient, but also very good for the environment. They are now able to, 71% of the time, fix the problem remotely. So no technician going on site or no machine coming into their organization. And then when they do have to send a technician, because they know the information and they've gotten all the diagnostic information before the technician goes on site, they are now able to fix the problem 92% of the time on the first visit. Again, preventing all of those truck rolls and really helping the environment. All right, so let's go to the last stage of the product life cycle, the end of life stage. Circularity is a critical need as we progress on our sustainability journey. Per our university advisors, the world is only 6% circular today, so we have a long way to go. Modular product design with associative disassembly procedures are a key driver towards this. Ideally, large assemblies at the end of life stage of the products may be disassembled and reused as spares in the supply warehouses, or others might be remanufactured into new products. Only as a really second to last resort would material be ground down and reprocessed into other components. Okay, so this morning we quickly went across the entire product life cycle, and I just shared some high-level examples of what is already possible today with rich data and leveraging it across the life cycle. My key message is that the key to sustainable physical products is the decisions that we make up in the design and engineering phases. These decisions impact 80% of the product's footprint, and the rich data created during that design phase can be used throughout the life cycle of the product. And while I showed you lots of examples of how companies are already using capabilities which are available today to create more sustainable products, from simulation-led design to AI to manufacturer process planning to IoT and augmented reality and modular design techniques, I believe that we're just getting started. For example, there is so much more we can do on materials. Which materials we use, how much we use, where we source them, and how to reuse at the end of life. We can also do so much more on reducing our energy requirements in manufacturing. In addition to the design decisions which require less energy to manufacture the product, we can also leverage IoT sensors and other information to ensure that we are manufacturing in as efficient a way as possible. This is same is true for managing waste. And while we're still at single digit in terms of achieving a circular economy, I truly believe that we will live into this circular economy with transparency of information and by leveraging design, manufacturing, and service enhancing tools, which will continue to improve over time. I hope you found this session informative, and again, thank you for the opportunity to speak to you today.